So today we're going to look at circles, and I think they're really cool. It's something I like to talk about in class, and it's just something that I think we've taught you for so long in your life, but if I asked you to give a definition of what's a circle, if you had to tell somebody else what's a circle, I think sometimes you can get kind of stumped. People tell me, well, it has 360 degrees, but my answer is, so does a square. It's that round thing. Well, an ellipse is kind of round too. So there has to be like, what is the formal addition? How do we talk about this in mathematics? And how can we write it down as an equation? So here's our definition. The definition of a circle is the set of all points equally distant from a set point C called the center. The distance from the center to any point on the circle is called the radius. So here you can see I have a little picture, and in the center I have HK, and that just shows here some point that I'm going to call the center. And then any point that we're just going to generically call XY, I have this distance. And if I were to take that distance this way, or in any direction I wanted to, this line segment wouldn't change. It would have that same distance. I think that's part of what's so cool about circles. Circles just kind of like encapsulate what's going on. So I notice all the time my Apple Watch will go off and it says, rain is detected within 5 miles of your location. And this is what I picture. I picture in this location, right? So like this big area, right? So 5 miles is a really big area. It's over 75 square miles. All these people have this chance of rain that's coming, or sometimes it'll say a mile, but whatever my app says, it'll just tell me how big this area is. I think you should also picture this as like an air tower, right? When they're looking at airplanes, they're going around and they're going, what's really close to us, right? So what's looking around? So you should think of this as monitors and stuff, things that we're looking at direction and how far things away are from us. And that's what we think of us. We're the center. That's how our society works, right? We're the center of everything. All right, so as we want to continue to talk about this, I want to be able to come up with an equation. Notice that was just a picture. So I just want to throw this back at you. Hopefully you've seen it somewhere. If not, no big deal. This is called the distance formula. So this says if I have any 2 points, and I decided our points would be x1, y1, and x2, y2, pretty normal, and I want to find out how far apart they are. Well, to figure out how far apart they are, do you see that this forms a right triangle? And this distance would be how far is this x to this x, so x2 minus x1, and how far is this y from this y, so that's y2 minus y1, and then you see this hypotenuse. So this is the Pythagorean theorem coming in here that we're saying, oh, if I want to find this distance, I would take the square root of this amount squared plus this amount squared to get this amount, right? So this is a squared plus b squared is c squared. We just take the square root to say, hey, let's just care about the distance. So this is we have change in x's squared plus change in y squared. I take the square root that tells me how far apart the points are. So why did I introduce that? Because I want to talk about a circle. So I'm going to mesh these two ideas together. So here's our picture of a circle again, and here's this distance equation. So what I want to point out to you is this HK, this is our center, so that's one of our points. And then our other point is this x1, y1. To make it look pretty, I'm going to put the x and y first. That's pretty much just all it is. It looks pretty that way. So I'm going to put this x here. And the other x is my h, so I have x minus h, so that's how far apart those are, squared, plus y minus k, how far apart they are, squared. Add them together, take the square root, that's our distance, and our distance, this point to this point, is what we called r. I think most of the time you guys don't like to look at something that already has a square root in it, so we can get rid of it. Square that, square this. Here's my pretty, now called the standard form of a circle. So this tells me if I have this equation, I know it's a circle, I know HK will be the center, and I know the radius will be r. So let's put that into action. So here's a circle. X minus 2 squared plus y minus 1 squared is 9. And why don't we graph it? So the first thing we're going to need to know before we can graph it is what would be the center. So the center is 2, 1. Notice x minus 2 becomes positive 2. Y minus 1 becomes positive 1. It's from that original format, so just remember, always flip them. And then the radius is not 9, it's the square root of 9, which is 3. So I went ahead and graphed it, and I want you to see this here. 2, 1, here, 2, 1. And then to draw it, I used a program, obviously, because I can't draw. But you can see 1, 2, 3 to the left, there's a point B. If I go 1, 2, 3 to the right, look, I'm on the circle again. 1, 2, 3 up, 1, 2, 3 down. These other parts, if I could draw line segments, would have a distance of 3, but since they're not just vertical or horizontal, a little bit harder to tell. But if I did have to draw it by hand, I would start with my center. I would go to the right, to the left, up, down, and do my best to connect the dots, but it wouldn't come out this pretty. So let's look at it again. I just changed the center and radius. So this time it says x plus 3 squared plus y plus 4 squared is 4. This time again, I really need to know what my center is before I can start. Remember, we're flipping them. So instead of 3, I have negative 3. Instead of 4, I have negative 4. And that 4, I take the square root and I get 2. Once again, I pulled up a program to be able to graph this. This is from GeoGebra, and I just snapshotted it in. You can see here, negative 3, negative 4, there is my center. And then again, if I go up 2, I'm on the circle. If I go down 2, I'm on the circle. Right 2, left 2. So everything is, all these points that form the circle are 2 units away from this center A. All right, so let's look at this one. Find the center and radius of the circle and graph. So this one I have x squared plus y squared. And do you notice you don't see an h and a k? Like there's not the x minus something going on. So since there's nothing going on, I know the center is at the origin, which is 0, 0. And the only thing I have this 1, I take the square root and still 1. So this really basic circle, x squared plus y squared is 1, we call this the unit circle. So I thought it would be a good thing to show you because you will hear unit circle again in your math lifetime. So you can see here's my center, 0, 0, 1 up, 1 down, 1 right, 1 left. Pretty little circle that you will be seeing again when you get to trigonometry. All right. Just because it's cute and I can show you, look how well I can graph now that I know circles, I made this kind of bullseye looking thing. And I wanted to just show you the different equations and how I got this. And this really does look like concentric circles that just kind of builds out from this. So this should look like something you've seen other places before. The first circle right here, that's the unit circle. X squared plus y squared is 1. I didn't write that one again. But then you can see the next one hits at 1.5. This one hits at 2, this one hits at 2.5. So I just wrote down my x squared plus y squared over and over is equal to 1.5 squared, which is 2.25, 2 squared, which is 4, and 2.5 squared, which is 6.25. All right, so let's look at this one. Again, I want to write the equation of the circle. So I would start by looking at, look at this is 4, and it goes up 2. So my center is 4, 2. And then the radius, I want to count how far it takes me to get over to the circle. So if I'm at A, and look, I go 1, 2, 3, there's my radius. Look, I could go this way too. 1, 2, 3. Or I could go 1, 2, 3. So any direction, I'm going to get 3. Remember to square that when you put in the equation. So I have x minus 4 squared plus y minus 2 squared is equal to 9. All right, so let's look at it in a different way. So this way I did not give you in standard form. I have x squared minus 4x plus y squared minus 6y is 12. So I don't have that perfect square form. So I'm going to have to create it. So first let's just kind of gather terms. So I put a parentheses around the 2 x's. I put a parenthesis around the 2 y's just so I can kind of separate them in my mind. And then I can go in and complete the square. So remember when you complete the square, you're looking at the term in front of the x. So just power 1x. I had a negative 4, I divided by 2 and square it. Same thing with the y. I had a negative 6, I divided by 2 and I square it. Now I've messed with what the left side is equal to. So I need to equally do the same thing on the right. So you see this repetition, this negative 4 over 2 squared, this negative 6 over 2 squared. I added to the left, I also add to the right. All right, let's simplify that. When I factor, this x squared minus 4x minus 4 over 2 squared becomes x minus 2. What I look at is the x squared becomes the x, negative 4 over 2 is negative 2. I like to leave this sign that was the coefficient of the x with the number when I divide by 2, so I know where to put it down here, and I remember my sign change if I have it or don't have it, so I like it to match. Same thing here. Y squared becomes y. Negative 6 over 2 is negative 3. So those are factored out. We force the factor and we know it's going to happen. I don't have to square this and factor. I know it's going to be x minus 2 and y minus 3. This I do need to fix. So 12 I left alone. Negative 4 over 2 is 2, but when I square it I get 4. Negative 6 over 2 is negative 3, but when I square it I get 9. All right, simplify that. 12, 4, and 9 gives me 25. Looking good. Now all I need to do is say the center is 2, 3, and my radius is 5. One more like that because I think it's always good to see another one. So this time I made it x squared plus 8x plus y squared minus 10y is 8. Once again, I started by grouping. Okay, so my x's together, my y's together. I take the 8, I divide by 2 and square it. I take the negative 10, I divide by 2 and square it. Okay, so it's always the coefficient of the power 1 term. When you do that, remember duplicate it. So 8 over 2 squared, 8 over 2 squared. Negative 10 over 2 squared, there it is again. So repeat yourself, that's important. Then, this whole thing, x squared plus 8x plus 8 over 2 squared becomes x plus 4 squared. Y squared minus 10y plus negative 10 over 2 squared becomes y minus 5 squared. So it becomes much, much shorter when I do this completing the square. 8, keep it. 8 over 2 is 4. When I square it, it's 16. Negative 10 over 2 is 5. Negative 5, really. Negative 5 squared is 25. When I simplify that, I'm really just simplifying the right side this time. I get 49. All right, so I have a center. Negative 4, positive 5, and a radius of 7. The last picture was just to show you some cool fractals that have to do with circles. I thought they were pretty. It shows you, I think math is fun. Yes, it has practical uses, but sometimes the use is just pretty. All right, that's it.